Good morning to all. Myself Vinod Kumar, Assistant Professor, Department of Civil Engineering, Roving College of Engineering and Technology. Today we are going to learn a topic: design of laterally supported solid hot rolled section beam. That is, a beam is a structural member that primarily function of which is supported load to its axis. The load produces bending and shear force in the beam. Rolled I section with or without cover plates are used. For floor beams, channel T and angle section are used for beams in roof truss as purlin and a common rafter. Depending upon the condition at the support, beam may be used. That is, simply supported beam or fixed beam or cantilever or propped cantilever and continuous. Failure of a beam can occur in several ways, such as bending failure, shear failure, deflection failure. Laterally supported beams. For the most of the rolled shape, the permissible stress in bending is equal to the 0.66 F5. The important condition associated with the use of values is that is member must have an axis of symmetry in the plane of the web. Member must be loaded in the plane of the web. The compression flange must be laterally supported. And then we should follow a design procedure for laterally supported beam. The first one is we have to calculate the bending moment, and second one is we have to calculate the section modulus, that is ZP Z, that is required is equal to m by Fi gamma m naught. The formula is m by Fi into gamma m naught, and then we have to select the suitable section from IS 800 code and then calculate the shear, and the formula is shear is equal to Vd is equal to Vn by gamma m naught, that is equal to where Vn is equal to Av Fi by root 3 into gamma m naught, where Av is equal to area of stress is equal to height into thickness, that is h into Tw into F by root 3 into gamma m naught, and then check for low shear or high shear. If V less than 0.6 d means this is low shear, if V greater than 0.6 means high shear, and then calculate the design moment capacity. The formula is taken from IS 8 2000 codebook, page number 57, class 8.2.1.1. That is M less than or equal to MD. If first condition is D by TW less than or equal to 0.67 E and V less than 0.6 D. For design moment capacity, if D by TW 0.67 is summation and V less than 0.6 D, then check the moment capacity carrying capacity, that is formula is MD is equal to beta P ZP Fi by gamma m naught. In two conditions, first one less than or equal to 1.2 ZT Fi by gamma m naught, and second condition is 1.5 ZB Fi by gamma m naught, and then check the bending moment condition. Let's see a problem. Design a simply supported beam of span 5 meter carrying a reinforced concrete floor capable of providing lateral restraint to the top flange compression flange. The uniformly distributed load is made up of 20 kN per meter and imposed load of 20 kN per meter and dead load itself. Assume Fe 410 grade steel used. Let's see a diagram. The span of L meter carrying a load W by first of all we should calculate the calculation of factor load, that is dead load is equal to 1.5 into 20. The question they will give it 20 kN, so we take the 20 kN. So dead load is equal to 1.5 into 20, that is 30 kN per meter, and the live load is equal to 1.5 into 20, that is 30 kN. Then total factor load is equal to add the dead load and live load, that is 30 plus 30 60 kN per meter, and the effective length of the beam is 5 meter. And then calculate the bending moment and shear force. For cantilever beam, a simply supported beam, the bending moment formula is WL square by 8, that is W is equal to 60 into length 5 square divided by 8 is equal to 187.5 kN meter, and then calculate the shear force. The shear force formula is WUL by 2, 60 into 5 by 2, that is 150 kN meter, and then calculate the section modulus. The formula is ZP record is equal to M by Fi into gamma m naught. M is equal to bending moment, that value is 197.5 into 10 power 6 by Fi value is constant. 250, and then gamma m naught is 1.1. The value is taken from the IS 800 2000 code book. While calculating, we'll get the section model. That value is 825 into 10 power 3 meter cube mm cube. Let us try ISLB 350 at 486 Newton per meter. The value is taken from SPS 16, page number 18, table number 2. Where H is equal to 350 to the mm, BF means width of the flange is equal to 82.5 mm, and thickness of the web, that is 7.4 mm, and thickness of the flange is equal to 11.4 mm, and radius equal to 16 mm, and the ZZ is equal to 13,200 mm per 4, and compare the section classification. Summation is equal to 250, formula is square root of 250 by f5, that is 250 by 250 is equal to 1, and then classify the what section is. By first one we have to calculate B by TF, that is 41.25 by TF value is 11.44 mm. While calculating, the value is 3.62, that is greater than 9.4. So the section is plastic section. And then calculate the check for strength, and the formula is taken from IS 800 2000, page number 59, class 18.8.4, where VD is equal to Vn by gamma m naught. The formula is H into TW F YW by root 3 into gamma m naught. While substituting the value, we will get the shear strength, that is 150 340 kilonewton per kilonewton, that is greater than 150 mm. And now check the high shear or low shear. That formula is 0.6 VD. That 0.6 into 340, that is 240 kilonewton, that is greater than 150. That indicate it should be in the low shear. And then check for moment carrying capacity, that is M greater than less than or equal to MD. The formula for moment carrying capacity is MD is equal to beta P ZP Fy by gamma m naught, less than or equal to 1.2 ZP Fy by gamma m naught. Where this section is plastic section, so take the beta P value is 1. Substituting the value, MD is equal to 1 into ZP value is 851.11 10 power 3 into 250 by 1.1 into 10 power 6. We will get the moment carrying capacity value is 193.43 kilonewton meter. And then check for deflection. Deflection formula is 5 WL power 4 by 384 EI. Well, substituting the value, 5 into W value is 20 into L value is 5000 divided by 384, E value is constant for Young's model 2 into 10 power 4, and I section IEZ is IXS value is 13,200 into 10 power 4. The deflection calculation is 6.165, hence the deflection is less than the allowable stress, hence it is safe. Thank you.